Have you ever looked down at your leg or your arm to find some cut and you have no idea where it came from or how you got it? So you put a Band-Aid on it and a few days later it's gone. It's all healed. And you don't even think anything of it, of the amazing process that caused this to happen. Or let's say you're looking at your nails and you notice that they're kind of jagged looking because they've really grown since the last time you cut them or filed them down. Or let's say you look in the mirror and you notice that you are a lot bigger than you were when you were 5 years old. What do all of these things have in common? All of these things have one thing in common, and that is mitosis. Mitosis is a type of cell division done by most of your body cells, and it's really important for cells to divide. If they didn't divide, you couldn't grow. I mean, how do you grow if you can't make more cells, right? So one reason why you're bigger than you were when you were 5 is mitosis. Mitosis also is great for repair of damage. If you have some kind of accident, like when we were talking about the cut on your arm or your leg, you want to make sure that it can get repaired. Well, you have to make more cells to do that. So mitosis is great for that. What mitosis is not, okay, it's really important to understand what it is not. It is not a process that makes sperm or egg cells, because that is something called meiosis, which sounds very much like mitosis, unfortunately, but it is a different process. Okay, mitosis is only done by body cells. Mitosis also makes identical cells. That is the goal, is identical cells. So if you're trying to make more skin cells to replace worn out or damaged cells, you don't want to start suddenly making stomach cells there. That would be ridiculous. You want to make sure you have identical cells replacing what was lost. So mitosis makes identical cells. Real important thing. Now, it's also important to understand that your cells are not dividing all the time. That would be a disaster. If all they did was divide, you would just have this rapid, crazy growth. In fact, that's kind of what cancer is. Cancer is uncontrolled cell growth. We have a great clip on the cell cycle and what the cell is usually doing most of its daily life, which is actually a phase called interphase, where it's growing and it's replicating its DNA and carrying out some of its cell processes. That's what it spends most of its time doing. But mitosis is a very short amount of time. But during that time, it's a very important process because this is where it is going to divide. Before we get into the steps of division, it's really important to understand that your cells have something inside them, an organelle called the nucleus. And the nucleus holds your DNA. DNA is really important because it's your genetic information. And if you're going to make more cells, you need to have the same DNA in those new cells as you did in the original cell. You want it to be identical, no mistakes. Very important. The problem is you've got a lot of DNA, and we've got to get that DNA into the new cells using mitosis. So there has to be a better way to organize that DNA. Like that DNA needs to go to the container store and get organized. Well, what actually happens is that DNA can be organized into these units called chromosomes. Chromosomes are made of DNA and protein. You've probably heard before that humans have 46 chromosomes. That means in human body cells, in the nuclei, that's the plural of nucleus, you don't say nucleuses, you say nuclei. In the nuclei, there are 46 chromosomes. So basically that means that DNA is organized in chromosomes. It also makes it a lot easier to move over when you're making new cells. Okay, now here's something that's tricky about mitosis that students get confused with. So if you have 46 chromosomes in a cell, you have to duplicate those chromosomes. That basically means you're duplicating DNA, because remember, chromosomes are made of DNA and protein. You're duplicating the chromosomes before you divide. You have to do that because if you're going to make an identical cell that has 46, well, you had to duplicate it before splitting. So if you look at our cell cycle video clip, we talk about an interphase, which is a stage that most of the time cells are in. They actually duplicate their DNA. So during that time, they would have duplicated their DNA. So instead of 46 chromosomes, during interphase, they would duplicate and have up to 92 chromosomes. So that when it gets to mitosis, they will be able to split into two cells that each have 46 chromosomes. And that will be identical to the original cell. So let's get right into the mitosis stages. I like to tell students to remember PMAT. It's a little acronym, helps you remember the P is for prophase, the M is for metaphase, the A is for anaphase, and the T is for telophase. So you can remember PMAT. That's the stages in order. So the very first step is prophase. Prophase, because it's the beginning step, the nucleus is still there, and it's going to go away in a little bit. So this is a stage where it's actually still there. And the chromosomes are visible. In fact, we say they're condensing, which means they're kind of thickening and visible. So prophase, very beginning step. The next stage is metaphase, M for metaphase, and I also like to remember the M for middle, because in this stage, the chromosomes line up in the middle of the cell. The nucleus has been disassembled, it's no longer there, so we've got the chromosomes in the middle, waiting there to be pulled apart for the next stage. Next, the A is for anaphase. In anaphase, I like to think of the A is for away. The chromosomes move away. They're moving to the opposite side of the cell. So they're kind of moving to the poles of the cell. Now, one thing to point out, these chromosomes are not just moving by themselves. They actually have something called spindles. These spindles are fibers that help move the chromosomes to the opposite ends. It kind of helps them move along. The last stage, the T, is for telophase. And in telophase, the chromosomes are actually at the complete opposite ends and new nuclei are forming on each side to make these two new cells. And they're starting to surround the chromosomes on both sides. So I like to think of the T is for 2 because in mitosis, you end with 2 cells. And again, remember, they are identical. You can really quiz yourself online with a lot of mitosis pictures. There's tons of mitosis quizzes online to practice being able to look at the cell picture and naming what stage it is. And remember, we really do care about mitosis because without it, we wouldn't understand how cells grow, how they repair damage, and it's really a lot of our cancer research is dependent on understanding mitosis because cancer itself is uncontrolled cell growth. So in other words, uncontrolled mitosis. Well, that's it for the Amoeba Sisters, and we remind you to stay curious.